Hello, ladies and gentlemen. I would like to welcome you at the last session of today's meeting of conference Smart City Symposium Prague 2021. This session is devoted to autonomous and electric vehicles. We have 7 contributions, and we will start with Marek Pirkel from Hikvision with his contribution called Smart Camera Systems. Please, stage is yours.
Good afternoon, everyone. Thank you for this opportunity to participate in this symposium. Hikvision is supporting this event for the first time. So I hope this is the beginning of some nice tradition. So let me, before you start with your main topic of this blog, let me introduce Hikvision and our point of view, the smart city solution or smart city concept, and why we're supporting events and congress like this. Hikvision is a global leader in security systems, mainly in smart camera systems. So we see smart city as a big opportunity for our products and systems. We recognize there are several levels where smart cameras can be used. For example, smart parking system, which were discussed a lot in previous blog. Then there is, of course, city surveillance system, security system of the city, several levels of this monitoring of security cameras. Big area, it's a traffic system, already discussed here also by other companies. And last but not least, there are environment systems where can be used smart cameras. I will show you how. Okay, so let's focus to every area. We have a smart parking system area where we have indoor parking systems, we have outdoor parking systems, and for all these applications can be used smart cameras. Smart cameras for indoor, for example, it's of course used for navigation to free parking slots, parking spaces. We use cameras with LED lamps or the LED navigation panels. For outside monitoring, we can monitoring parking places, or as you can see on the right side, side parking of the streets. All these systems must be connected to some good navigation system, and the data can be shared to the other city applications. So this is one example. Next area, as I mentioned, is a city surveillance system. When as latest trends show us and our experiences, it's very important to use several levels of coverage of city. As you can see here, it's some ground control systems, it's mobile control systems, and it's, if it's possible, it's according to every country and its law, air control systems. All these systems used very modern cameras, which is equipped with AI, deep learning features, functionalities. These functionalities came to us a few last years, so we are very happy because video analytics of cameras now are in very high level. So we not only get high level picture from cameras in almost any lighting conditions nowadays, but we also use cameras as sensors, and we can use computing power of these cameras to get interesting and important information for city real-time monitoring, or some analytics for, let's say, big data, cloud computing, every possibility you can imagine, and were discussed today. So again, some some examples, simple examples. This is air control units, as I mentioned. So this is cameras placed on drones or on the top of the high buildings. Technically, for information, we achieved in ultra zoom cameras up to 50 times zoom ratio, and in panoramatic cameras, for example, we achieve up to 40 megapixels in resolution. So you can imagine it's a huge amount of data which can be used. In mobile systems, we can have here several examples. For example, a personal camera for security services on the streets, which help them to monitor or to evaluate some incidents, and to be online in touch with a monitoring center. Of course, there is mobile cameras to cars, which used in police cars, and we are able to monitor and, for example, read license plates during driving and at higher and higher speeds. So it's very, very interesting applications also. Another area which I mentioned at the beginning, it's traffic system. Already discussed a lot in this symposium. Our inputs here are smart traffic cameras, which are able to help to traffic flow, help to evaluate incidents, monitor situations. For us drivers, unfortunately, the modern ITS cameras can also detect traffic violations. For example, red light crossing or illegal parking, driving in opposite direction, and so on, speed section measurement, and so on. But all these data, all these data can be used in some umbrella monitoring software, which can use this data for some real-time calculations applications. You can see dashboards made by us, but we can share our data. We can fuse and integrate with other city systems to, of course, to make some final goal, and this is some open ecosystem of security and safe smart city. So traffic, and last but not least, this environment point of view. The smart city must be able to handle with different aspects of city life. For example, fire protection, danger of fire, or floods, for example. So now here we can see smart thermal cameras, which can detect even where it's starting fire for a long distance, or inside of cities, some burning rubbish and something like that. And on the opposite danger, water, we have special algorithms for cameras which can automatically detect and read level of water of rivers and water dumps. So basically, this is very briefly overview of Hikvision's point of view to smart city solution, and I thank you again for this opportunity and for your attention.
Okay, so seems to that you finished before your reserved time, so that's perfect.
Sure.
Thank you very much on behalf of the auditorium for your presentation. Maybe we will see how many questions are. So, okay. So maybe you all already showed a lot of applications of your smart camera systems. Maybe one question is what are your nearest plans and what are the future plans for evolving your system?
Yes, the nearest future plans are mainly orientated to let's say the third stage of smart city development, as we internally called, and it is the fusion with um, cities systems which can use data from our cameras. So it's a cooperation with third-party partners to create some let's say solution which is suitable for uh, cities, medium-sized, bigger sized capitals, and so on. So it's a cooperation with our technical partners because we give our inputs, our hardware, partly software, but it's about cooperation. So parking systems are very interesting for us. Public transportation, I forgot to mention, trams and buses are very big applications for us, and it's also part of smart cities. So this cooperation with technological partners and improving our hardware with this cooperation, it's I think our
Okay.
biggest and nearest plans.
So great. I wish you success with the implementation, and we are looking forward to see it maybe in Prague.
Thank you. Yeah.
Okay, thank you for your presentation, and we will move on in our program. So the next contributions come from Germany, from Hamburger Hochbahn, will be given by Markus Dietmansberger, and it's called Modeling and Evaluation of System Cost and CO2 Emissions when Electrifying Bus Fleets. So please, Markus, the stage is yours.
Thank you very much for the introduction. I hope you can hear me and see my screen. Yes, here in Hamburg, I tried to give you a short overview about my presentation. So I will first introduce the Hochbahn because I'm quite sure that not everybody knows what the Hochbahn is doing. And afterwards, a short brief review to the political mission, and then finally to the results, which should be the most interesting fact of the presentation, of course. So first, about the Hochbahn, we are operating about 1,000 buses in the city of Hamburg, Germany. And those of you who have been to Hamburg before, it's 18 times walking down the Reeperbahn. And here in Hamburg, we have a political mission. So from last year onwards, we are not allowed to buy any more diesel buses. So we are forced to buy emission-free buses. And we have to finish the process of transforming the fleet by 2030. So this is the challenge that we are facing. And from this challenge, we did some analysis, some investigation on which is the best way and how to save money and how to save emissions. And these are the results I would like to show you now. So the first result I would like to show you is how much money you have to spend when you move your fleet from diesel to electric buses. So here we can see the comparison. So when you move to battery buses in Hamburg, you roughly have to pay 1/3 more of euros in order to operate your fleet. We have a comparison here from the diesel, which is the very right column, to the 3 different types of battery electric bus systems. And the first message that I would give is that the most important additional costs come from the vehicle and battery costs, obviously. So here in this sector, we see that definitely the costs for the buses and the batteries are way too high in order to be competitive with diesel. But still, there are chances. So, for example, the costs for electricity is comparable with the costs for the diesel. Next, I would like to take a quick look about on the CO2 emissions in the system. So how many CO2 emissions can you save? This is the good news. So you can save at least 2/3 of CO2 emissions, as we can see in the comparison here. So the most important fact is, again, the battery production. So most of you might know that the manufacturing of the battery is quite energy consuming. And this is what we try to model in a worst case assumption. And thus, of course, the results are less good than should be in the reality. But the basic message that we can give, even with the worst case consumption and assumption, to come up with a saving of 2/3 of the CO2 emissions of the whole bus system. And another interesting finding, which will conclude my presentation, is the fact that it's quite important to match the buses and batteries lifetime, which we can see here now. So you can see here a comparison of the estimated lifetimes for the buses and the batteries, estimated lifetimes from 10, 12, 14, and 16 years, which is quite common in the bus operation area. And you can see that respective of the battery lifetime and the bus lifetime, the combination of the two is very important to get an optimum of the lowest costs. So it's not so easy to say you have to use the bus as long as possible, because it might be even worse to use the bus longer when you have to buy an additional battery, which is quite obvious, but here you can see the results, how these effects counteract against each other. And this should be everything I would like to tell you. I'm open for questions if you have some. Thank you.
Okay, Marcus, thank you very much for your presentation. We still have a little time for possible questions. I will look for the questions from audience. We have none, but maybe I got on one question when looking at your charts. How did you calculate it into your review? Also, the electrical energy mix. Are you sure about the outcome for the reduction of CO2 also in your area energetical mix?
So this basically was one of the easiest questions to answer. So how much is the CO2 emissions from the electric consumption, so from the electric energy that goes into the bus? And we balanced this with zero, because at the Hochbahn we buy, let's say, the highest possible quality of ecological energy that you are able to buy on the market. So green energy, and yeah, of course we can produce our electricity on our own by using PV or wind turbines, but this is balanced with zero.
Okay, thank you. So it sounds very good. Thank you again, and we will continue to the next speaker, who is Marcel Fetter from Budapest University of Technology and Economics, and his contribution is called Multi-Criteria Evaluation Method for Operating Battery Electric Rail Cars. So, if Marcel from Budapest is ready, please. Okay, and if not, maybe I would like to ask auditorium, people who are watching us online, to send possible questions for discussion, which can be also done at the end of this session, but primarily at the end of each presentation, so that we can immediately get feedback from the presenter. So, okay, maybe we have some technical problems with our next presenter, who should be able in a couple of seconds to show his presentation. As I see our IT guys, they are working hard, and now we are on. Okay, so Marcel, please, stage is yours, and present your contribution.
Thank you very much, and good afternoon. I am Marcel Fetter from the Budapest University of Technology and Economics, and I would like to welcome you to my presentation about multi-criteria evaluation method for operating battery electric rail cars. First, I would like to talk about the present issues and the present situation regarding our topic. First, the modal split of rail transport and the share of rail transport in the modal split is is not too high nowadays, but rail transport is a most eco-friendly transportation system. So therefore, it would be optimal to get a higher share of this transportation system. In Europe, there are many non-electrified regional railway lines where still many diesel fuel vehicles are in operation instead of the use of alternative fuels and batteries. The solution to these problems may be the use of battery electric rail cars that have zero local emission. Unfortunately, many railway operators don't have enough experience with these vehicles yet. So in our research, we focused on to show the use of these vehicles, and we examined 4 different types of battery electric rail cars. Also, we developed an evaluation method that helps to identify the effects of charging infrastructure development, and also it helps to compare battery electric rail cars and different railway lines. First, in order to use the evaluation method, we need different characteristics. For example, characteristics of railway lines, of different rail cars, and also passenger traffic. If we have these characteristics, then we can do the evaluation process, and at the end we get an applicability value that helps us to find the best railway lines and the best rail car combination where it would be optimal to use these battery electric rail cars. The evaluation method has different aspects that we developed, and each aspect is evaluated on a scale from 1 to 5, where 1 point means low applicability and 5 point means high applicability. The evaluation aspects that we developed are the following: railway line electrification, battery capacity utilization, railway track conditions, economy of scale, and volume of passenger traffic. Because of the short time period, I I'm not able to tell more details about these aspects right now, but it can be found detailed in our paper. Also, we included a case study that shows the use of the evaluation method. We evaluated 5 different types of railway lines in Hungary with 4 battery electric rail cars. The results of the evaluation method that we presented in our case study assist to find the best route with the best vehicle combination. As you can see, railway line number 1 and Stadler-Fürth-Aku rail car got the highest point, and therefore that would be the optimal to use in the future. In conclusion, we developed a multi-criteria evaluation method for battery electric rail cars that helps to minimize operational costs, but at the same time it maximizes environmental and passenger traffic benefits. Also, the key finding of our research was that railway lines electrified in 40 to 60% are the most suitable for battery electric rail car operation. Thank you very much for your kind attention.
Thank you very much for your interesting presentation of your research around the battery or hybrid rail cars. We still have a little time for discussion, But unfortunately, there is no question from auditorium, so I would like to ask you some, let's say, naive question, but how much we need to pay in advance or in addition for the battery equipped rail car or EMU, comparing with the similar or same sized electric vehicles. So how much it is just in order of magnitude?
Thank you very much for your question. Around 40 to 60%, it is higher to operate battery electric rear cars, but by the time and development as it is going to be passing and going through, it will get closer to the nowadays used diesel fueled vehicles.
So you expect that as in the case of electric cars, it will somehow, the gap will be lowered in time, how they will be developed and sold in higher series. Yeah, it's so.
Yes, it is expected.
Okay, so thank you again. Thank you for your
Thank you
presentation
very
and
much.
answering my questions. And we will move from Hungary to the south of the United States, to the University of Texas in El Paso. And the next presenter is Kevin Chu with his presentation called Locations and Lengths of Entrances and Exits of an Automated Truck Lane on a US Freeway. So Kevin, stage is yours, please.
Thank you, Mr. Chairman. My name is Calvin Chiu. I'll be presenting this paper, Location and Length of Entrances and Exits of an Automated Truck Lanes on a US Freeway. This paper has three authors, Himana Haurigui, Jeffrey Weiner, and myself. And the project is sponsored by the C2 Smart Center, which is the Smart City Center for Transportation, sponsored by United States Department of Transportation. So let's first define the problem we are trying to solve. Automated truck lane is expected to be very fast gaining popularity in the US. However, there's no existing guideline for automated truck lane design, and we review the existing documents and find that there's this problem that we need to solve when designing automated truck lane. The situation is, if you look at the bottom of the screen, when the truck enter the freeway or expressway on the right, it needs to move across all the lanes to the left and enter the US freeway. And when the truck exit from the truck lane, it needs to move all the way from the left to the right in order to exit the freeway. So the distance between the freeway entrance and the entrance to the truck lane is X. The lane between the actual normal general purpose lane and to the truck lane, the opening for the entrance and exit is Y. So in this problem, we are trying to solve how much should be allocated for the distance of X and Y. So we consulted the Texas Department of Transportation, which is the authority in the state in charge of highway transport. They provided us with the future design of the truck lane, as you can see from the figure. The standard configuration is there are three general purpose lane on the right, and the truck lane is on the left. And there are 10-foot wide shoulder, which can be used for the additional lane for the truck to move in and out between the truck lane and the general purpose lane. So having decided on the lane configurations, we selected a site for the simulation experiment. We performed the experiment by vSim simulation, and we decided on the three value of X and three value of Y in the experiment. And the combination of it produces 9 design scenarios of X and Y, plus one scenario of no automated truck lane. And we were us to perform the simulation analysis for the year 2045, and the traffic volume was obtained from the planning organization in El Paso, and what they provided us with the official traffic forecast for the year 2045, and we also assume that of all the trucks that were forecasted, 50% are conventional trucks, another 50% are automated trucks. So to simulate the scenarios in VSIM, we have to create a new type of vehicle, automated truck, because they follow each other with a very small headway, almost like a platoon or convoy of a train. And on this screen, it shows how the truck lanes were configured in the simulation model. So at the side, there were 4 entrances and exit. Okay, and these are the major exits and entrance to the alternate routes where the truck can enter and exit the expressway or freeway. And we further put 4 sensors locations, sensor stations at these entrances and exit to measure the traffic conditions. So this slide show 3 figures of the output. Basically, the left-hand side, left top graph plot the volume and density relationships, or different colors or different symbols represent the data collected at different stations. And you can see that follow the traditional theoretical model of speed, density, and volume relationship. Now, however, when we plot the speed versus x plus y, we find that in one of the stations, the speed actually increases when the x and y distances increase. That means the operating speed will be reduced if the design of x and y is not adequate for the truck to interact with the general traffic when they move across the 3 lanes. So the conclusion is we recommended that the x, which is the distance between the freeway entrance and the entrance to the truck lane, should be 3.2 kilometers of the 3 distance tested, and the opening between the general purpose lane and the truck lane should be about 730 meters or 300 feet for the truck to move in and out. And for future work, we would like to test out with different volume of traffic, different percentage of trucks, and expand it to select different sites. So at the end of the presentation, we would like to thank C2 Smart Research Center, Texas Department of Transportation, and the El Paso Metropolitan Planning Organization for assistance in providing the data for this research. Thank you.
Thank you for your interesting presentation and the result of your simulated experiments. Maybe I have a little question, because we are out of time, but small one. You have the plan for 2045 to have 50% of automatic trucks, as I understood from your scenario. What is the situation now in Texas? Are there some automated vehicles or freight vehicles already on the highway to be seen?
They're not in commercial operations. They are still in the experimental stage. Several big truck company already they already own trucks, and they are driving it, testing it on the actual route with other vehicles, but with the human drivers actually sitting at the driving seat.
Okay, so we will need still wait a little.
Yeah, we are not at the level 5 yet.
Okay, thank you very much. Thank you again for your presentation. And we will now come back to Prague, to Czech Republic, with next presenter, who is Přemysl Toman from Czech Technical University in Prague. And he will present his contribution named Study of Driving Specifics of the Electric and Conventional Powered Two-Wheeler Users. So, Josef, who is also co-author of this contribution, will probably start the presentation.
Thank you and good afternoon. My name is Josef Svoboda, and I'm going to present you the first part of our paper, which is called Study of Riding Specifics of the Electric and Conventional Powered Two-Wheeler Users. The main motivation to write this paper was rapidly increasing ratio of electric-powered motorbikes across micromobility shared services. The electric-powered bikes bring specifics for the rider in sense of motorcycle control because electric powertrain has different features that rider has to deal with and which is he not primarily trained for. This article aims to the specifics of riding the electric motorcycle compared to the conventional petrol powertrain. According to the previous research, we define three hypotheses to verify in real experiment. The first one is that the rider on the electric powered motorcycle adapts speed differently than on conventional petrol motorcycle. The next one is that the EMC rider tends to accelerate and decelerate stronger. And the last one is that electric powered motorcycle has worse riding parameters. The experiment was performed on a 1 kilometer long circuit with the same rider. The rider complete 9 laps with electric and 9 laps with petrol bike, in which the driving dynamics data were measured. The motorcycle were built as part of a student project, and the bikes had similar setup, the same time of tire, the same performance category, and very similar chassis. The measured data were after evaluated in developed MATLAB-based application. We use several methods to interpret the measured data. Below on the slide, you can see an example of traction circles that combined longitudinal and lateral acceleration. The shape of graph, for example, tells how much the rider applies the trail braking or how hard he accelerates while leaning over exit of corners. These graphs shows differences in control of both motorcycle. For example, the petrol bike was more agile. The rider on this bike was more stable, and he was able to use a larger range of lateral and longitudinal acceleration. Now I pass the word to my colleague Przemek.
Thank you, Pepa. So let me introduce you. My name is Przemek Hutama, and I will go through the second part of our article, our presentations. So I will continue with results. Not only traction circles were evaluated, we evaluated as well the whole circuit and the speed profiles, and in detail 3 selected curves, because they were selected one fast one, the C1, one technical one, C2, and one with a very bad side condition. So it's C3. And we did the evaluation lap to lap, and we focused on parameters measured directly on the bike, such as leaning angle, rolling activities, rolling angles, and the braking lateral Gs. And of course, we defined intersections, entrance, speeds. The important mention is it's important to mention that on the motorcycle the rider has 0 HMI, so there were no dashboard, so the behavior was adapted only by his feelings. And according to this, we did the correlations of the data across the bikes. For the discussion of our initial hypothesis, we see in our results contradictory trends of starts to braking distances. It's earlier on an electric motorcycle than on petrol, and the entry velocity to the section was higher on an electric bike. So it's linked to our second hypothesis that as the EMC is one gear motor, so one gear acceleration, the rider was always on a gas in abbreviation and on a brake, so he tended to accelerate more when he was not leaned, and he had actually no recuperation, no engine braking, so the riding was even more demanding for
for the right speed in each corner. And it's seen as well in traction circles in an area where the petrol case, the centroid is located in a negative, so we can see the influence of engine braking, the more decelerations in general than on an electric bike. And according to worst dynamic parameters hypothesis, we see that the petrol bike was ridden more agile with the rider than the electric bike. That is linked to the lower rolling activities on the electric bike. To sum up somehow all this article, we can see that the rider has to adapt the behavior. There are differences in corner and in general on riding this bike, and the handling of the electric motorcycle is tends to be more demanding because it contains more braking, and for the general outcomes, the electric powered vehicles are very rarely part of the general driving school, and they are, on the other hand, so easy to access in a city. And so it's very important to set the recuperation similar to petrol engine braking as the initial, let's say, feature, because that's what riders are used to and trained for, and that's something what they can expect. And of course, we have to face the changes of the usual behavior of riders, because as we predict more and more these bikes in the streets and more potential users, we have to train them for this kind of mobility. So thank you very much for attention, and let us say thank you from this slide with my colleague.
So thank you very much both, Přemysl and Josef, for your very interesting presentation of not only of the experiment, but also presentation of your motorcycle. Maybe I have one short question. What do you think about how it will affect the driving strategies with respect to battery capacities, which are always the problem of electric road vehicles?
That's why we are focusing. I will try to answer that. I think for the city and for urban areas, when the distances are in tens of kilometers, the battery capacity is okay even now, because for this kind of trips you don't have to care much about this. But for longer distances, you have to you have to have very good planning, because motorcycle is always something that gives you freedom, and this takes it back. So for longer distances, and now it's not that, let's say, user friendly.
Okay, so thank you again, and we have now the time to move to other presentation, which will be again from Czech Technical University in Prague by Alina Maško, who will present her contribution called Microsimulation Model for Assessment of eHMI of Autonomous Vehicles. So Alina, stage is yours. So Alina has some technical difficulties, as I can understand. So Alina will be the last presenter of today's session number 5, session Autonomous and Electric Vehicles. And after this session, the main part of the conference, or today's program, will end, and our colleague Ondřej Přibyl will announce you some very special event, but this will go after we will finish Alina's presentation, which, as I see, should start in a couple of seconds. So maybe we can. Okay, so Alina is online again. So please, stage is yours and present us your contribution.
Hello, I'm going to present a model that was designed to evaluate the external interface of autonomous vehicles on the example of the scenario close to pedestrian crossing or at the pedestrian crossing, and to evaluate the efficiency of autonomous vehicles communication interface to pedestrians. Based on the current situation when autonomous vehicles are not yet in on the roads, people are used to communication with drivers who are driving the cars, and which is currently the natural or intuitive behavior of people. And with introduction of autonomous vehicles and where driver is not delivering the message of how vehicle is going to behave, this communication will be transferred to the exterior of the vehicle and to providing the messages so that they would be understandable by people, by pedestrians. And such efficiency would highly contribute to traffic safety, to safety of vulnerable traffic participants such as pedestrians, and not only but also the two-wheeler riders and so on. In most of the interfaces introduced by or suggested, the design interfaces that are introduced by manufacturers of autonomous vehicles, there is a wide diversity of designs, and it requires extended testing procedures, experimental testing with participation of subjects, and which is time and financially consuming, and with a big and there is still no standardization on that aspect for development of such designs. And based on the related research, we can say that most of the interfaces are graphical. It is some image, a hologram, or something displayed on the car body of the vehicle. Either there are some projections that are illuminated on the nearby infrastructure. And our method is was designed. Was developed for evaluation of design of these messages to be displayed on vehicle car body based on this interface area's location, and in relation to subject. That is to say, based on the location of the subject, their height, it could be determined how efficiently this interface is located and how visible it is to the subjects, and based on the field of view of a human. There are two calculation methods in this in these simulation models. One of them is geometric, one of them is graphical, and one of them is based on field of view of a human, and another one is based on the simulated scene in the virtual scene in the evaluation software. Based on these micro simulations and evaluated 7 types of interfaces, we have reached some results for the examples, and were able to provide some assessments of them. One of the outcomes of this method is visibility density value, which is based on the area which is in the field of view of the subject, and per that we could say if this or that interface or per its position where it is located on the car vehicle body, how it is visible to the subject. And for example, per the results, we could say that location in the bumper area, or vehicle mask which is also in the bumper area, it would be appropriate to provide different another kind of message, especially that would be efficient for the pedestrians who are approaching the pedestrian crossing in the direction of the vehicle movement. And as for the road projections, for the road projection notification, the best results were obtained when subjects were in close area to the vehicle. Another outcome of this method is the efficiency, which stands for how well the projection is rotated towards the subject, and from the interfaces assessed, that the LED part was found to be the most efficient in comparison to the rest of the interfaces, and for example, hood and road projection had low value of the efficiency. So that's all from me in this presentation. If you have any questions, I will reply them happily. Otherwise, we have more details and this method description in our paper.
So, Alina, thank you very much for your presentation, which was the closing presentation of session number 5, and in fact the last presentation in our scientific program of the first day of Smart City Symposium Prague 2021. But I would like to invite here my colleague Ondřej Přibyl, who has a special announcement for you. So Ondřej, seat is yours.
Thank you, Peter. So, as you can see, that was the end of official part of today. But, as you can see, now the unofficial part starts. We will have a delay of about 10 minutes, so we will start at 4 o'clock and 10 minutes. And there will be a concert of Duo Professores. We will play, together with my colleague Miroslav, few pieces from several authors. The first will be concerto from Oskar Rieding. That's a violin concerto. Unfortunately, we don't have violin, we don't have an orchestra, so we will try to manage with the instruments we have at hand. After that, we will play several pieces by Astor Piazzolla. And well, I must admit it's a coincidence, but Astor Piazzolla would be celebrating 100th birthday this year. So it's really, I am pretty sure you will get to hear quite a lot of Piazzolla this year, and in my opinion, it's a really good thing because the music is very interesting. There are some Argentinian tangos, etc. Very nice music. I hope you will enjoy it as well. And at the end, we will be playing Waltz by Dmitri Shostakovich. That's also a piece that I like, but please be careful since it's very catchy. So even my small child is running around at home and humming a melody from this Shostakovich's Waltz. Anyway, if you can grab some wine, and I'm looking forward to see you in a little bit on our performance. And please don't forget that tomorrow at 9 a.m. local time, we have this workshop dealing with tools, challenges, stakeholders in the field of traffic assessment. So we are looking forward to that. And thank you very much for your attention the whole day today. Thank you. Bye.